Assalamualaikum and hello everyone. Welcome to the video for 5.2 Alkene, where in this video we will continue to learn to outline the mechanism in dehydration of alcohol. Okay, on your notes it will be on page 19. Okay, for the dehydration of alcohol, what we're going to remove is actually dehydration. We remove water from our alcohol itself. So since this removal of molecule, hence this is an elimination reaction. Okay, so how do we remove the atom or remove the water itself? So let's look for the reaction of 2-butanol. Okay, so for 2-butanol, it means that we have 4 carbon, 1, 2, 3, 4. And 2, it means that on carbon number 2, so contohnya sini carbon number 2, we have OH. So the rest of it, we're going to fill out with our hydrogen. Okay, so how we will remove the H2O? First, we're going to remove the OH from our carbon OH lah, which in this case is our OH here. Next is actually we remove the hydrogen, but for the removal of hydrogen, it can't be from the same carbon lah. Cannot be this hydrogen. We're going to remove the hydrogen from the carbon next to the COH. So here is actually a carbon. So we're going to remove the hydrogen. So it's either from your right hand side or your left hand side. But then we have to consider the classification of the carbon or the hydrogen itself to determine the major minor product. Okay, so let's look here. We have 2 carbon kan. Dia punya body card we have 2 carbon. Next is determine the class. Okay, so what I'm going to do is actually I'm going to classify the carbon itself. Sebab the hydrogen, the classification of hydrogen depends on the classification of carbon. Okay, so this one on your left hand side ni, this carbon only attached to 1 carbon. So it means that this carbon is a primary carbon. And on the right hand side, this carbon attached to it ada 1, 2 carbon. So this will be my secondary carbon, and the hydrogen will be secondary hydrogen as well lah. Okay, so since we have 2 different classification, we will have 2 different product. So in this case, we have to consider yang major minor tu kan. So first thing, because we have secondary and primary, so from here, this is our major, this one will be our minor lah. So it means that the secondary will be the major one, primary will be the minor product. Okay, so how to write down the equation? Okay, so first possibility is actually when remove the hydrogen from the secondary. So when remove the hydrogen from the secondary hydrogen, so it means that we remove OH here and we remove hydrogen here. Okay, so what will be the product? So it means that we're gonna remove this OH. Okay, and this case I want to remove the hydrogen from secondary, so remove lah yang ini. So what happened here is actually when we remove these 2 atoms, so we're gonna form our double bond here. In between the atom that, in between the carbon that has lost an atom ataupun lost hydrogen and our OH. So this is the first possibility. Since this is the one that we remove the hydrogen, so this will be our major lah. Okay, next possibility is actually when we have remove the OH and the hydrogen from the primary itself. So we have to show for the reaction equation, we have to show both lah, primary and secondary. So for our major then and minor. So for this case around, we're still gonna remove the OH. First step, remove the OH first. Okay, next step, we're gonna remove yang hydrogen from primary pula. So this one we remove here. So the one that we lost the atom, so we're gonna take put our double bond. Okay, so this is actually the product. Okay, so then we have to label which one is major, which one is minor. So this case, secondary ni, when remove the OH and hydrogen from secondary will be major. Remove OH and hydrogen from primary will be the minor product. Okay, so this is the reaction equation. So from here, we know that this is the major product. Then we can do the mechanism lah. For the mechanism, usually, most of the time, we will do the mechanism for our major product. Okay, so for the mechanism, for this part, I haven't included the step 1, step 2, step 3. But it's fine, you're going to write it yourself. We're going to write down only step 1, step 1 here, step 2, step 3 itself. Okay, so let's look for the reaction. Again, this is for 2-butanol. Okay, so first reaction, step 1 is that we will react our alcohol with our H2SO4 ataupun HOSO. But what I'm going to write down here, okay, step 1. Okay, so what happened? Okay, so this time around, if you don't want to do the expanded part, it's fine. This one, how do I get here? It's actually this carbon is this one. Attached to it, we have our OH, we have our hydrogen. Okay, this one, the carbon on the left hand side ni is actually CH3. And on our right hand side is CH2, CH3. Okay, so for the mechanism, it is not restricted to, okay, for this one must be condensed je semua or must be expanded je semua. It can be a combination lah. But the most important thing, you have to include all the atom from the molecule itself. Okay, kalau our assignment, yes, we have to be very specific, expanded and for all of the atoms. For the mechanism, it can be combined. Okay, so if you want to write down in terms of expanded for all of the mechanism, no problem. But here I'm just going to show for step 1, step 2, I'm going to use this one. Okay, so for the first reaction, what would happen is that we will react it with H2SO4. In this case, we're going to use HOSA. Okay, remember, step 1 is the protonation of alcohol, where the OH ni will take the hydrogen. Okay, so that's why we're going to write down in terms of HOSA. Okay, so again, what about the mechanism? Okay, the mechanism, it will move from the rich electron to poor electron. Case electron ni dia baik. Yang kaya akan cari yang miskin untuk dermakan dia punya electron. Okay, so which one is the rich electron? The one that has lone pair. Actually, oxygen ni we have our lone pair here. So, how is the movement of electron? It will be towards hydrogen. From the oxygen ni towards our hydrogen, curve arrow. Okay, and then make sure it is actually full head arrow. Okay, so once the oxygen take the hydrogen, the bond will break. Okay, but then when the bond break, the electron here will be split. It will not be split equally. It will move towards more electronegative atom. So between hydrogen and oxygen is more electronegative. So we have to show from the bond here will be moving towards oxygen. Okay, so what happened next is actually for the case of our product here, it will not be alcohol. It will change to, instead of here, it will become OH2 because it already taken the hydrogen from our HOSA. And then, since it has donated the 2 electron towards the hydrogen kan, they take the hydrogen to they donate the electron here, we're going to show that it has positively sign on oxygen. It must be on the oxygen lah. What happened to HOSA? HOSA akan jadi OSA. OSA ni, for the case of OSA, remember, once the oxygen accept the electron, it will become a negatively charged. Okay, remember, donate, if it's donate the electron, positive. If it accept, it will become a negatively charged. Okay, so that is for step 1. Okay, step 2, what would happen is actually the formation of carbocation or the removal of our H2O. Okay, H2O right now, dia jadi H2O plus, right? Okay, for water itself, it want to be a water molecule lah, a neutral molecule itself. So this bond will break. Okay, so what happened here? I'm going to take the product from our second step. Okay, and then I'm going to take this one. Okay, so from here, what would happen is that this bond will break as the water will remain, or we're going to have our byproduct lah. Byproduct for this reaction is water, right? So we want to remove the water from this molecule itself. We want to remove the OH2 plus to become H2O. Okay, so again, when this bond break, the electron, since it will be a heterotic cleavage, it will be moving towards more electronegative atom. Between carbon and oxygen is more electronegative. So we have to show the electron will be moving towards oxygen. Okay, so what happened here is actually for our product. So for the product itself, we will remove the water lah from this molecule. Okay, but then because consider the carbon has donated the electron towards the oxygen kan, maknanya the electron ikut the oxygen, so it means that the carbon has positively charged on it, the formation of carbocation. And what happened to our water? We have to show lah, plus H2O. Okay, so that is actually step 1 and step 2. Okay, last step is actually the formation of alkene too. We're going to remove one of the hydrogen. Okay, for the removal of hydrogen, the step 3, I'm going to use back my expanded N. So it will be easier for you lah to see which hydrogen that can be removed. Okay, so this is actually the structure. For the expanded one, it will become like this. Okay, why? Remember that CH3 here is my CH3 here. My carbocation, attached to it hydrogen. Okay, and attached to carbocation ion CH2, CH3. Here CH2, here is my CH3. So this will be my step 3. So what happened to the step 3 itself? Okay, so let's look here. Step 3. What happens is that we're going to remove the hydrogen. Okay, remove the hydrogen to form cation, to form our alkene. But then, our also here, our catalyst here will take back the hydrogen to form also, or the H2SO4. So again, okay, the hydrogen, okay, it will be taken from step 3 ni. It will be taken the hydrogen from next to the carbocation. Okay, so if it's next to the carbocation itself, as we can see, we have two different classification kan, which we have classified at the start of the reaction equation. Here is primary, here is secondary. So again, when the also take the hydrogen from the secondary, it will be our major product. It will form our major product here. So, which hydrogen that could be taken? Kat sini boleh, sini pun boleh. So here, the movement must be from rich to poor, kaya kepada miskin. Which one is the rich one? Must be from our oxygen lah, ada negatively charged ni. It will take the hydrogen to form our Hausach back. So, curve arrow, lepas tu full head arrow. Okay, so here will be our Hausach. Okay, but what happened here is actually, okay, the hydrogen, the electron ni will be moving towards carbon, and then carbon ni will be share the electron with our carbocation ion. Or, the shortcut of it, kita show lah. Yang ini bond ni collapse towards this one to form our, dia daripada jenis ni kan, dia terus jadi macam ni, our alkene. Okay, so what will be the product itself? So here will be the product. So this one. So it means that, again, we remove the hydrogen, we remove the bond, okay, and then remove classification, yeah. Okay, so here will be the electron. Electron on the carbon itself. So the electron on the carbon ni will be sharing the electron with our carbocation. Okay, since our carbocation ni dah accept electron, so it become a negatively charged. So once it become negatively charged, kan positive negative cancel out lah. So this one padam, this one padam. We will form our product. Okay, so that is actually the mechanism for butanol. Make sure for the hydrogen itself, the hydrogen must be taken not from our carbocation ion, we must taken from the hydrogen next to it. Macam kita consider remove hydrogen from next to the carbon OH lah. So from next to it, consider the classification. Here because we have secondary primary, so we take the hydrogen from secondary. If we have hydrogen on tertiary, contohnya on right hand side tertiary, left hand side secondary, we're going to take the hydrogen from tertiary lah. Remember, the more stable tu, it will become the major product. Okay, so that is actually for 2-butanol. Now let's continue with the reaction for the dehydration of 3-methyl-butanol. So again, butanol, so it means that we have 4 carbon, and on carbon number 2 we have OH. It's just that here on carbon number 3 we have our methyl. Okay, so that is for the reaction. Okay, so right now, again, what we're going to do is actually for dehydration of alcohol, we're going to remove OH, and then we're going to remove the hydrogen. For the removal of hydrogen, we're going to look at the carbon next to the COH lah, for this part. Okay, so we're going to remove the OH here. Okay, and then from the hydrogen, we're going to look from the carbon next to it. So here we have one carbon. On the left hand side of this, we have this carbon which is only attached to one carbon, so this is a primary carbon. Okay, on the right hand side, here we have our carbon. This one is attached to 3 carbons. So this one is a tertiary carbon, and hence this is our tertiary hydrogen. Okay, so it means that here we have 2 different classes, so we have 2 different products. We have our major and minor product. Okay, so first possibility, again, tertiary is more stable, so it become our, when we remove the hydrogen from tertiary, it will be the major product itself. Okay, so let's look for the reaction, the reaction equation here. So here we're going to remove the OH, and then we're going to remove the hydrogen from our tertiary carbon. So tertiary carbon ni memang only has one hydrogen, this one only kan. So we're going to remove this one lah. So remove this one, and we're going to remove the bond. So next what we're going to add, we're going to add our double bond here. So that is the first possibility. Okay, the second possibility is actually when we remove the OH and then we remove the hydrogen from the primary carbon. So what will be the product here? So again, we're going to take this one plus. So which atom we're going to remove? Remove the OH. Okay, and then next what we're going to remove? Remove yang hydrogen from our primary pula. So we're going to remove this one, and then we're going to remove the bond. So what we're going to add next is our double bond. Okay, so basically that is our reaction equation. Okay, so next what we're going to do is do the mechanism. But first, since we have these two kan, we have to label lah which one major, which one minor. Again, from the classification, since we have our tertiary, when remove the hydrogen from tertiary, it will be the major product. Hence, the primary, the hydrogen which is removed from the primary carbon, that will be our minor product. Okay, so I'm just going to label it here. Okay, so this is the reaction equation. Okay, next step is actually we're going to do the mechanism. Remember, we want to write down the major product lah to get the major product. Okay, so here for step 1 and step 2 is the same as the two butanol. So here I'm just going to fast forward it lah. Okay, but right now, for the step 2, there's an extra step here. Here it mentioned that rearrangement can occur. Okay, so how about the rearrangement ni? Okay, so yang ni yang new stuff for us to look at. Okay, so for the carbocation, what we're going to do is actually I'm going to label the carbocation ion and the carbon next to it. Yang sebelah-sebelah dia. So here is actually the left hand side ni primary. This one is secondary. This one is tertiary. Again, how do I get it? Primary ni they only attached to one carbon. Secondary ni attached to 1, 2 carbon. Tertiary ni attached to 1, 2, 3 carbon. Okay, so right now, actually this one can rearrange. Why? Because actually for the carbocation ion, if you still remember from 4.4, the stability of carbocation ion is that tertiary is more stable than secondary carbocation ion and secondary is more stable than primary carbocation ion. Okay, carbocation ion is actually poor electron species. Hint dia sebab dia positif lah kan. Okay, so for the carbocation ion, the more alkyl group attached to it, more carbon attached to it, more stable. Because yang alkyl group ni is actually electron donating group. Ataupun kita kata dia sugar daddy kita kan. So dia ni poor electron. Kalau boleh, kita ni dia dah miskin kan. Kalau boleh lagi nak banyak sugar daddy lah. So sekarang ni, our carbocation ion only has 2 sugar daddy dia. 1 alkyl group, 2 alkyl group. So actually bila kita tengok next to it ada tertiary tau. So what happen is that kalau boleh kau dah ada 2 sugar daddy, kau boleh lagi stabil, kau boleh dia nak dah 3 sugar daddy tu. Okay, so what happen here for the rearrangement can occur for our syllabus, we're only gonna learn 2 stuff. It's actually we're gonna learn about the 1, 2 hydride shift dengan 1, 2 CH3 shift. Okay, so okay, later I'm gonna do some example on Google Form. Just nak confirm kan, just for you to see lah. For the case of hydride shift ataupun 1, 2 CH3 shift. Okay, so what happened here is actually positively charged ni, it would swap position with the hydrogen. Okay, so kenapa dia nak swap position dengan yang hydrogen ni? So that our primary ni, daripada 2 sugar daddy, kau boleh nak 3 sugar daddy. Okay, sebab dia tak nak lah swap the position with the primary ni. Nanti kurang sugar daddy dia tak nak lah. Okay, so what happened here is that, okay, from here, actually dia akan tukar for the case of carbocation tu, dia akan shift sama ada shift to the one on its right ataupun the one on its left lah. So it's either right or left. Dia tak boleh jauh-jauh sangat. Okay, it's either here or here. So what happened here is that we're going to shift these two. We're going to change it. So dekat sini what I'm going to do is actually I'm just going to circle yang positif ni dengan hydrogen ni, kita akan shift the position. So what happened next? Biar kita tengok. Kita akan shift the position. Here is my positive, here is my hydrogen. Dah shift position kan? And then when we check the classification, this one is still primary, this one is secondary, this one is tertiary. Okay, so bila kita tengok dekat sini, sekarang ni carbocation is the most stable one because it can be a tertiary carbocation. Sebab dia lagi stabil kan? Kita dah ada 1, 2, 3 sugar daddy, 3 alkyl group attached to it. Okay, and this process is what we call, we have to label it as 1,2 hydride shift. Okay, why hydride shift? Because actually we're changing or we're swapping the position of positive carbocation and with the hydrogen. Yang 1, 2 ni, it means that carbon number 1, carbon number 2. We're attaching yang ni carbon yang betul-betul sebelah dengan dia lah. Sebenarnya in hydride shift ada 1, 3, ada 1, 4. Tapi 1, 2 ni, it does not mean yang position sini carbon number 1, number 2, number 3, number 4. No. When we're talking about the shift ni kan, 1, 2 carbon kan. Carbon, one of the carbon here, carbon here dengan carbon next to it. So jadi 1, 2 je lah, betul-betul jiran sebelah. So 1, 2 hydride shift. So actually sebenarnya kita akan belajar there's 1, 2 hydride shift, ada juga 1, 2 CH3 shift. Okay, so kenapa dekat sini ni baru ada 1, 2 hydride shift? Sebelum ni tak ada belajar pun 1, 2 shift ni. So when we look back, dekat sini, when we look here, our carbocation here is actually a secondary carbocation. On the left hand side there is actually primary. This carbon attached to 1, 2 carbon. So this is secondary carbocation. Secondary carbon. So does it need to shift? Sebab sama je kan classification dia. So there's no need to shift. This one, sebelah dengan dia, ada yang it can be more stable. Lagi banyak sugar daddy. So dia lagi suka macam tu lah. So this is actually our formation of carbocation. So nanti don't worry, I'm gonna add in the Google form. Is this reaction gonna form 1, 2 hydride shift or not? Ataupun 1, 2 CH3 shift. Okay, so step 3, deprotonation. So deprotonation is still the same as before. Okay, where we're gonna take, in this case kita we will not take this one lah. We will take the one yang dah formation of the most stable carbocation. Okay, so that's the last step of it. So again, for the deprotonation ni, when you remove the hydrogen, kena tengok lah. Check memang next to the carbocation. Sekarang ni carbocation kita dah tempat position lain kan. We still have to check the hydrogen on the left hand side and on the right hand side as well as the left hand side. So you will get your product. So this case, for the next mechanism, we will always take into account for the carbocation ni, see if rearrangement can occur or not. So again, you can check it again, and then we're gonna look. Jangan risau, this is not the only example that we will see the rearrangement. Okay, so later we're gonna look at more of the examples. Okay, so that's it for this video.